Everybody loves elephant toothpaste, including my students. I've got one of my students with me in the lab today. He wanted to try something, and we want to show you. This is Colin. How you doing?
Good, how are you?
So what are we going to do today?
We have a catalyst here filled of potassium iodide,
Okay.
some food coloring, some distilled water, and soap. And we are going to decompose the hydrogen peroxide.
That's this stuff right here. Sounds good. Let's try it. All right, so we're going to pour it at the same time. All right. We're going to do this demo two different ways. The first way is using manganese dioxide. And the second is using the potassium iodide catalyst that Colin prepared. Go ahead. And now we add the peroxide. All right, ready? 1, 2, 3. Yours is better than mine. Substantially better. Oh, mine's getting better. Have you ever had an upset stomach and you take an Alka-Seltzer? Let's look at how they work from a chemical perspective. The package says it contains anhydrous citric acid and some aspirin, that's for pain relief, and some sodium bicarbonate. That sounds to me like we've got an acid and a base situation. So let's make a sample. I'm going to add a little universal indicator so we can see how the pH changes. We notice the color go from orange to green as the citric acid is neutralized by the baking soda, making in essence a buffer. Buffers resist changes in pH. Check out what happens when I add a strong acid. Who doesn't love a moisture-sensitive reaction? I've pre-massed a mixture of ammonium nitrate and ammonium chloride salts. I'm going to add them into the evaporating dish. Now I'm going to add and mix the zinc powder. In case you're wondering, yes, I'm doing this in the fume hood. I just happen to have a huge fume hood. We're going to initiate the reaction by adding a little bit of water to that mixture. Now there's two things going on here. The first, chloride ions in the ammonium chloride catalyze the decomposition of ammonium nitrate, which gives off lots of heat and lots of gas. That heat causes a secondary reaction between zinc and the ammonium nitrate to make zinc oxide, which is what we see in that white puff of smoke, as well as the visible light that's emitted through this reaction. So what should we do in the lab today? Another potassium video? Nah, let's do sodium instead. Just like potassium, we store sodium in oil because of its reactivity with oxygen in the air and its violent reaction with water. It's also a fairly soft metal. It's conductive just like elemental potassium. And it reacts with water too. Check it out. Safety first. I've got something I want to show you. We're going to start by making an aqueous solution of this stuff. So I have a nice blue solution of copper 2 chloride. Now we're going to add some aluminum. Let's see what happens. Next, a flame test. We're going to ignite those gas bubbles and see what happens. Are you at home and bored? Looking for something to do? If you have some diapers, I've got an experiment for you to try. Disposable diapers contain sodium polyacrylate. Let me show you how you can extract it. Start by opening up the diaper and loosening up the material in the middle. Next, you're going to carefully cut just through the top layer of the diaper from front to back. Or back to front, doesn't really matter. Then get yourself a Ziploc bag and stick that diaper inside the zip. Seal it up, shake it. You should notice some granules that look kind of like white sand accumulate in the corner of the Ziploc bag. That's the stuff you want. Throw everything else away, save the good stuff. Yes. So what happens if you take dry ice, like this, and you react it with a pretty reactive metal, like magnesium? Let's find out. So we've got a nice pile of magnesium turnings in a crater inside the dry ice, solid carbon dioxide. Now it's time to light it on fire. This reaction actually causes the carbon atoms in carbon dioxide to be reduced, and we're left with this black, pure carbon material. Dry ice experiments? Yes. Don't forget this stuff is cold. Wear some gloves. Get a decent sized container. Then grab some bubble solution. Doesn't really matter which kind. Add a chunk of dry ice, which will start to sublime as soon as it hits the water's surface. It'll make an invisible layer of carbon dioxide, which is more dense than air. You can show that by blowing some bubbles on top and getting them to float. Check it out.
Now what you hear is not a test. I'm rapping to the beat. Now me, the crew, and my friends are gonna try to move your feet. See, I am Damien, and I'd like to say hello to the black, to the white, the red, and the brown, to the purple and
That's
yellow.
sweet.
But first, I gotta
To do it right, you can even get blobs of bubbles to hover and stay there for a long time, at least until they pop. Other experiments that you can do with dry ice. So this is just tap water. I'm going to add some universal indicator. Now check out what happens when I add the dry ice into the same. Let's talk water treatment, or as I like to say, get the flock out of here. To clean this, we'll need some of this and some of this. Mix them together and they make flock. And here's what it looks like. Use a screen to get those big chunks out first. This is the before. Now let's make the flock. Drop in a stirring bar. Calcium oxide. And now the aluminum sulfate. Stir it up. That's the flock. Turn it off and let it settle. The solution clarifies as the flock settles to the bottom of the container, taking any colloidal particles with it. And that's the first step to how our water gets cleaned. Share this video with someone who needs some science. This is just one of my favorite demonstrations, so I thought I'd show it to you. It's pretty simple. You only need 2 ingredients: potassium chlorate for oxygen generation and a fuel source. We're going to use a gummy bear. You've got to heat the potassium chlorate for a bit to start releasing oxygen gas. Now it's all molten and bubbly. Add the gummy bear. Now that's what I call exothermic. All right, so I showed my last period class a demo, and then they had an idea. They came up with this, and this is my class.
Renegade!
So here's what's going on with this smiley heart. We've got baking soda for the eyes and the mouth, lithium chloride around the perimeter of the heart, and then a copper 2 chloride rim. We're going to put some methanol on it, and then we're going to ignite it. Oh. All right, well, that was different.
It's so
Red.
Now we're seeing that reaction between the copper and the aluminum. Oh, now it's going red. I think that's pretty cool.